Hello, 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 and you are welcome to episode 5 of our AI for Human series. Last week, we were able to establish what AI models are files that save connections between numbers, right? Every word you have converted to a number, then the connection is saved. And that file is the model. And that file is where your systems like your LLMs, like your ChatGPT and the likes, ChatGPT and the likes would go check the file, check the model, look for the connection between the question you asked and look at what it is closely connected to, and then give you an answer. And we're able to show a live example of boy and man, the connection between boy and youth, boy and teenager. It was a very insightful section. Now, the next question that was ahead of us was how do you train the models? Those connections between the words, how do we establish them? And what exactly does it mean, right? When we say weights or adjusting the weights, how do we adjust the weights and do stuff like that? That was where we left it off last week. So let's talk about training models this week. Okay. We're going to start with very simple intuition. I think I like that word so much. And that intuition would be about a bike. So let me ask you, how did you learn to ride a bike? I'm pretty sure a very large amount of you learns to ride a bike, and I'm assuming you know how to ride a bike. You learned to ride a bike from a friend, maybe from your dad, someone taught you. And most likely they did not teach you things like when you get on the bike, you need to monitor your momentum, you need to be balanced on this edge, you need to consider the airspeed, you need to consider velocity. No one taught you that. If you even learned it yourself, you probably learned in this method, right? You got on the bike, you rode for a few seconds, and then you fell. And then you got on it again, and then you wobbled, and then you fell. You did it again, you fell, you did it again, you wobbled, you fell to the left, you fell to the right, and your first try was probably bad. The second time you came, probably on the second day, you wobbled a bit, but you did not fall. You achieved balance, but you were still not correct. And then you kept going. You probably fell once or twice. And then from a bit of wobbling, you eventually got how to ride a bike. This process, this exact loop you've seen, okay, maybe not a loop from first sight, but this process is the exact way we train machines, models, right? Remember, the model is the file in the machine where the machine goes to look for connection so that it can give you an answer. This is how we train models. It is a try and error method. Now, let's think of it like this. We'll give you a step-by-step flow of what it means to train a machine and how exactly do we mean by a try and an error method, right? So this is the sync. Let me scroll here a bit. This is the sync. The machine is actually trained through 4 steps. Okay. The first step is very accurate, a guess. If it's given a question, an image, anything, it will make a guess. When it guesses, it will then check whether its guess is correct. After it checks, it will check if there is an error. Now, if it is correct, it's just outputs correct. But if there is an error, it would log its error. It would put its error in, record the error, and then it would adjust based on the error and guess again. Now, humans learn like this, actually. It's just, ideally, it's sometimes different. Think of it. When we show a machine, remember, in this case, we are giving the machine so many examples, right? We're giving it so many examples, and we said, okay, this is example of for someone who is learning to draw a bike. Every time that person fell down, 4 million dogs, I probably shouldn't work there. So these are 1 million dogs, 1 million cats. We have fed it into the machine. We've shown it so many examples of dogs and cats and dogs and cats, and we're like, here you go. Don't ever make mistakes. But obviously, it's a try and error method. So I want you to realize that machines don't see images the way we see them. the machine does not look at see its color the way you see color. Actually, it sees them as numbers. Now, how does it do that? Something we're going to discuss much later. But just realize now that everything you feed to the machine, every word, every number, every picture, every number itself is converted into machine language, which is where numbers, and then it interprets it. So we pass the picture to the machine. We now pass a new picture to the machine. After training it on so much data, we pass a new picture to the machine and say, what is this image? Right? And you do it a lot to your ChatGPT. You pass it, you send images to it and you say, what is this? Google Lens. You send a picture to it and you say, what is this? Now, during training, what it does is it looks at the picture and it gives us an answer. And we say, okay, if that picture originally was a dog, right? If the machine tells us it is a cat, we say no. Now, this is the machine guessing, right? We say no, that is not a cat. Then the machine goes back and it looks at its error. And what is its error there? It says, okay, how wrong was I? Now, remember I said it sees it as numbers, right? And I would not go deep into this, but remember that it sees that number. So everything it is doing is a calculation. In the last class, we established that boy and man can have 0.9. Boy and youth can have 0.8, right? Those are the numbers. So if this picture, the difference between the picture, the weight there was 0.6, but the machine used 0.4. It will now say, oh, how far was I from the actual results? And we'll say, okay, 0.4, 0.6. Okay, so I was 0.2 different. That is when it adjusts. And after adjusting, it will now go back and guess again. This is very, very important for anyone to understand the concept of models and how they make decisions, right? Because what we do is that after adjusting these weights, we repeat it over and over and over and over again. That's what we mean by training. All right. Now, this is how it works. Think about it logically with your brain. There was something we used to do then in school. I mean, for those of us who are still in school, I remember we used to have what was it? Quantitative reasoning. No, okay, let me use new general mathematics. Oh yeah, new general. That was my math textbook in school, new general mathematics. And whenever we had a question, whenever we're solving probably a math question, it probably was surds or indices or logarithms, and you were not very sure, right? Probably you're not very accustomed to that subject. You've not paid so much attention to it, so you're just doing stuff. So now we go and we solve the exercises. When you solve an exercise, let's say the question is log 10 log 100 to base 10, right? And let's say you're not very good at logarithms, so you're not sure if your solution was correct, so you got 3. Remember what you do? You go to the back of the book, and when you get to the back of the book, you see that your answer was what? It's actually 2. So what would you do? You would then come back and say, my answer was 2. This here, what you've done, you've guessed, right? Now, you come here and you check. I say, oh, my answer is 2. It's supposed to be 2, not 3. Okay, so so the difference between 2 and 3 is what? 1. This is adjusting. So, okay, my answer is I'm supposed to get 1, right? And in this case, let's believe you are doing wuru to the answer. You're trying to, be smart about it. So you don't know how to get 3. You don't know how to get 2, but you're just trying to be smart about it. So okay, if my answer is 2, that means I have to reduce by 1. So then I go back again and then I guess. I'm like, okay, how can I manipulate this thing in such a way that it will give me 2? This is machine learning. So all your life you've been doing this. I mean, I don't mean you've been doing this, but once in a while, you must have done something like this, right? Or probably you're in the exam hall, you see your answer, you've solved the question, and you overhear someone say the answer is 28 and you got 32. At least you look at it like, oh, there must be a difference, 28 and 32, 4. So you go back into it and you start looking at which parameters you can adjust so that you can get that 32. Okay, at least the answer is 28 and your answer was not G. If it's that case, then there's no hope for you. But you get it. So the machines are going through a loop, and the loop is they will guess, they will check, they would account for error, adjust, and then guess again. That's how it works. Now, we understand the basic process of learning. It's not that complicated, at least on paper. Remember that the machine has the capacity to do this millions upon millions or billions of times in a few hours, right? So it doesn't take so long time compared to what it used to be in the past. It doesn't take so many time. So every time you go on Google Lens and you give it a picture, see, and this is where you reason to understand the concept of prediction. So you give it a picture and you say, let's say you took a picture of a house. Sorry, this is not an ideal house, but you took a picture of a house and you pass it to Google Lens and you say, Google, hey Google, what is this, right? Is this what is this? And Google comes back and tells you, oh, this is a house. I say, Google is smart. Not really. Google has just seen so many million pictures of this house and it gives it to you. Whenever you see cases, okay, let me not go there yet, but sometimes it's wrong. And why it is wrong is because it has not been trained so well on that example. So probably you see something very rare. I remember one time we went on a trip and someone found I think it was a leaf. Yeah, it was a plant. And we took the picture on Google Lens and we sent it and Google responded, but the answer wasn't correct because that wasn't the name of the plant. That's because it has not been trained on that type of data extensively so that it can identify it over and over again. So it begins to hallucinate. We're going to get there in a bit. So now, what exactly do we mean? Go back to the bike. Remember we said that for someone, I don't know why, I always thought I was able to draw a bike, but apparently I cannot draw a bike. So anyways, for someone who's going to ride a bike, every time the person fell down, the person's brain was adjusting. You see, most times you're riding and then you realize that you bent too much to the left. So what do? You now try to stay more on the right. If you fall to the right, then you try to stay more towards the middle. And if you fall a bit here, little by little, you are doing what? At this point, all you are doing is you are guessing, then you checked, then you'd adjust based on the previous mistake you made, and then you guess again. Machine learning. That's it. That's what they keep doing. So we keep doing that, right? And remember that in this case, we know the answer. That's what we are feeding. That's what we're feeding to the machine. Like we feed an image that we know what that image is. We know the answer to the machine, so that when the machine outputs a wrong result, we can easily tell it, no, this is the right result, and it would check to be able to adjust. What can go wrong? One might say, oh, this is simple. I'll just train the machine and do that. What can go wrong? Let's go back to the class analogy. Imagine someone who was learning or some other form of math. And what the student did was went to the textbook, right? Went to his textbook. It is not even good. So the student goes to his textbook and the teacher tells them, study, because all your questions will come from calculus. And then the student memorizes all the examples. So all the examples, memorizes everything. So he knows that if I see this question, this is the answer. If I see this question, this is the answer. He crams all of the examples, right? What will happen is when it gets to, and I know this has happened a lot to most people, where like your teacher gives you examples in class and then you see the classwork and you're like, this is completely different. It doesn't even relate to what we're taught. By the time the student gets to the point of seeing the assignment and he sees a completely different question, what happened? The student is lost. He's not able to solve it. This happens in AI too. In AI, we call it overfitting. So the concept here is that you give the machine, the model memorize the data instead of learning the pattern. Do you understand? The model memorize data instead of learning the pattern. And a very good way to explain this is, imagine you have a class of students now. You say, I want you to understand the 9 times table. You told them you want them to understand. So what they did, 9 times 1, 9, 9 times 2, 18, 9 times 3, 27, 9 times 4, 36, all the way down to 9 times 12, right? The student, they memorize the data all the way down to 9 times 12. Now, here's the problem. They did not understand that the difference between both is just add 9. Right? They did not understand it. All they did was 9 times 1, 9, 9 times 2, 18, 9 times 3, 27. They memorized it. They memorized it. So what will happen is when you get to 9 times 13, the student will be stuck because he only memorized up to the point of what? 9 times 12. Right? That's the only thing the student memorized. 9 times 12. And then, okay, sorry, I didn't, 9 times 12, 108, right? Okay. Now, the student memorized only to the point of 9 times 12. When he got to 9 times 13, he did not realize that all he has to do is add 9 to this and get a response. No, all response, a result rather. Here, the student does not know because the student was just what? Memorizing. The student has done what we call overfitting. Overfitting is memorizing the data but not learning the pattern. So here, the student did not understand that plus 9 is the pattern. It only memorized the data. Machines also make this mistake, and it's a very big deal in data science because like we are always paying attention to making sure that these things do not happen. So remember, what have we learned today is that training is at the heart of AI. Like you need to be able to, it's the chest, right? If you don't train, the AI cannot give you results. You see, everything else, ChatGPT, image generators, coding agents, everything else comes back to the loop. Remember, and that loop is very important. Everything else comes back to our loop, which is guess, check, error, and adjust. It must guess, check, error, adjust, and it will guess again, right? Guess, check, error, adjust, check again. So accounting for the error and then check again. Now, with what we have established here, the next question is, how does the machine know how wrong it is, right? Imagine we tell the machine, this picture is a picture of a cat, but you said the answer is dog. Now, how does the machine know that? Okay, how does it know how to adjust? Like, okay, this is cat, this is dog. What is the difference? How does it know that? And that's what we're going to talk about. AI's, what do I call it? AI's report card. Yeah, remember I was talking about class all day. So next, we're going to be talking about AI's report card, which is something we call the loss function, right? So the loss function. This loss function is what lets AI know you are far from the answer or you are close to the answer. And I promise you, it's actually more interesting than it sounds. So once again, if this was really, really insightful, helping you to understand like, oh, this is how it works. You know, that moment, if you're in that, oh, moment, share this with a friend, right? And at the end of the day, you're going to understand why does your ChatGPT why does it give you wrong answers? We're going to discuss that. We've seen one reason, which is overfitting, right? We've seen one reason, which is overfitting. Like sometimes it did not learn, it just memorized. That's one reason why your models sometimes will give you wrong answers. That's one. Along the line, you're still going to be understanding more of how these models work. And even in your conversations, you can be able to like, explain stuff to people and prove that you're actually the 1% of people that know what happens to AI under the hood. So next episode 6, we're going to be discussing our loss function.